This is section 6.2, page 2. So we're going to do this problem here that says, how are angle R and angle T related? Well, if we look here, we see that we have a polygon that's inscribed in that circle. So we know now that that means opposite angles are supplementary. Okay, so they are supplementary. Since opposite angles of a cyclic polygon are supplementary. And this is a cyclic polygon. All right, so if we're told that the measure of angle R, or find measure of angle R if measure of angle T is 112. So we know that this is 112, so all we have to do is subtract that from 180. So we know the measure of angle R plus the measure of angle T equals 180. Okay, and then if we know that T is 112, we put that in, and we can solve for R. So we're going to subtract 112, and what's left? 68. So the measure of angle R is equal to 68 degrees. And we're done. Okay, on to this definition. A polygon is circumscribed about a circle if all sides of the polygon are line segments tangent to the circle. So take a look here. It's saying that this, excuse me, this triangle is circumscribed about the circle. Okay, so all of these are tangent. They touch in one point. All right, the circle is inscribed in the polygon, so the circle is inside. So just remember, when you say inscribed, it's just like saying inside. Think of it that way, inside. Okay, so let's try this problem. Triangle ABC is blank about circle D. Well, the triangle is the outside one, so it is circumscribed. All right. What about circle D? It's the inside one, so it is inscribed. Okay. Now go on to the quadrilateral. Quadrilateral MNPQ is what about the circle? Circumscribed. And circle O is inside, so it's inscribed. Okay, so just practicing the terminology there. Okay, on to theorem 6.2.2. The measure of an angle formed by two chords that intersect within the circle. So here we have two chords intersecting inside the circle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let's look at this. We're talking about the measure of angle 1. Okay, so this satisfies two chords intersecting, okay, inside the circle, equal to 1/2. So let's put 1/2 down. Now, what comes next is the sum of, so we need two things, and we're going to add them together. The measures of the arcs intercepted by the angle. So here's the arc intercepted by the angle, so the measure of arc AC, plus the intercepted arc of the vertical angle. So here its vertical angle is 2, so that's going to be here, dB. All right, so that's the measure of angle 1. Measure of angle 2 now, it's the same sort of thing. We're going to say 1/2 the sum of its own angle. Well, let's just go across here first. Its intercepted angle will be AC. It's a little easier to see what's going on if I do it this way. Plus its own arc, so dB. Okay, now I want you to look at these two. Notice they are exactly the same. Shouldn't they be? What do we know about vertical angles? These are vertical angles. Angle 1 and angle 2 are vertical angles. So their measures should be equal. And notice they are. These two things are exactly the same. Remember, we had this was at the end of section 6.1. We were asked to determine whether the statement was true if we did it two different ways, and one of the ways we were doing it was using this formula. So now we actually have it as a theorem. Okay, so let's go ahead and do an example that takes this into account here. So we have given that the measure of angle 1 is 63 degrees. So let's go ahead and mark that, 63 degrees. And then we have the measure of the arc, RS, is equal to 3x plus 6. So let's go ahead and label that as 3x plus 6. And then the measure of arc VT, right here, is equal to x. Okay? And we're asked to find the measure of this arc, RS. Okay, so when we look at this picture, we notice that they're giving us these two arcs here. And we notice that the angles we're talking about have an intersection. The vertex of the angle is inside the circle, but not on the center. So we're going to use the formula in this theorem above here. So they've given us the measure of angle 1. So let's go ahead. We can write down the measure of angle 1. Let's write let's write of angle 1. Of angle 1 is inside circle, but not center. Okay, so what is the formula? It says 1/2 the measure of the intercepted arc. So that would be RS and TV. Okay, so what do we get there? We get 1/2. What's the measure of arc RS? Well, it's 3x plus 6. What's the measure of arc TV? It's x. One other thing I forgot to put in. We also know the measure of angle 1. So let's put that in as 63 degrees. Okay, so now what are we going to do? We're going to say 63 degrees equals 1/2. Let's add inside the parentheses. We get 4x plus 6. These are our like terms here. Okay? So then when we distribute the 1/2, 1/2 times 4x is just 2x. And 1/2 of 6 is just 3. So solving this, we're going to subtract 3. Subtract 3. We get 60 degrees equals 2x. And divide by 2. Divide by 2, we get that x equals 30. So they want us to find the measure of arc RS. All we have to do there is say it's equal to 3x plus 6. Put our 30 in and we'll have our answer. So what do we get there? We get 90 plus 6, or 96 degrees. And that's our answer. That concludes page 2.